Object-oriented programming is often defined by concepts like classes, inheritance, and encapsulation, while functional programming is associated with immutability, purity, and recursion. But these are not useful definitions of the paradigms themselves. They are merely concepts for implementing software in the said paradigm. In this video, we're not necessarily learning to write code in these paradigms. We're learning what they are and how to think in them. Let's imagine a non-tech savvy person who is writing a simple to-do list for their housework. Their list might be sorted by the urgency of the tasks, or not at all. This kind of sorting might work great for short, simple lists, but becomes unmanageable as the list grows and other people start to get involved. One alternative method for better manageability is to group together tasks by how similar the activity is. Fixing the car and the dishwasher together might make sense if you already have your toolbox out, or maybe washing the dishes and the car in succession avoids wasting water. Another approach is to group tasks together by the subject of the task. Maybe the father of the family is responsible for the car and wants all the car-related tasks grouped together, while the mother is responsible for all the food-related tasks. In this case, it would be better to group tasks based on not their actions, but on the subjects of these actions. These three methods of managing a simple housework to-do list are examples of procedural, functional, and object-oriented mindsets. This shows that these paradigms aren't about the tools or keywords we use in our code. They're more about how we structure our software and thoughts. Now that we understand the paradigms better, we can explore why functional and object-oriented are the only two main paradigms and how they fundamentally tie back to how our computers work. In 1936, a machine capable of solving any computer algorithm was invented. Its inventor and a great mathematician called Alan Turing proved that what we now call computers only need two concepts to solve any computational problem: data and operations. Data is what is stored inside the computer's memory, while operations are what the processor does to that data. And while deep down all data is stored as binary ones and zeros, the way we represent that binary is via different data types, such as integers, floats, and strings. These data types and operations can be mapped into a two-dimensional table that indicates which operations can be used with which data types. And as some of you may have guessed, the same mapping can be done in two different ways: operations listed under data types, the object-oriented way, or data types listed under operations, the functional way. And while there are dozens of other programming paradigms for implementing software specifically, due to the nature of our computers, they are all just different variations or hybrids of object-oriented and functional mindsets. At the end of the day, both paradigms lead into the same operations and data inside our computer, so they're merely a tool for us humans to think and model our software in. Whichever you choose and practice should be based on personal preferences and the nature of the problem, not on cult-like mentality of one being objectively better than the other. Thank you for watching, but remember, I am just another software engineer.